Jack.
I'm Braden.
And this video is going to show you how physics and concepts learned in physics can be applied to the game of hockey.
Our first few videos are going to focus on Newton's 3 laws, which are very important to physics.
The first law states that any object will continue moving in a straight path or remain at rest unless an outside force acts on it. As you can see here, the puck moves at a constant velocity in a straight line because there is little or no force acting on it. Newton's second law of motion states that the net force on an object is proportional to both the mass and the acceleration. This is where we get the equation net force equals mass times acceleration.
With this equation, if the net force is constant, a greater mass will have a lesser acceleration, and a lesser mass will have a greater acceleration.
When an equal force is applied on two different objects, you can see that the object with less mass is given more acceleration and goes farther.
Newton's third law states that if object A exerts a force on object B will exert an equal and opposite force on object A.
Here we see the puck exerting a force on the wall. The wall exerts an equal and opposite force back at the puck, which causes it to bounce back.
When multiple forces act on one object, they are added together as vectors. The force of the stick flexing against the ice is added to the force generated by the swing, thus creating a greater force on the puck. When vectors are added in two dimensions, they are added using trigonometry. When a hockey player strides, part of the force pushing against the ice is away from the skater, and part of it is pushing straight back. The part pushing away needs to be counteracted by the force exerted by the skater's other leg. Then the only remaining force is the force pushing the skater straight forward.
Centripetal force is the force that acts on an object to make it move in a circular path. Centripetal force always acts towards the center of the circular path. When the force stops acting on the object will continue to move in a straight line tangent to its former circular path.
Centripetal force is used in the high Z because it is an easy way to generate more velocity with less force exerted. The centripetal force is exerted on the puck by the stick, and when it is released, it continues in a straight path tangent to the circle.
Impulse is measured as a force over an amount of time. Momentum is measured as mass times velocity. By the impulse-momentum theorem, we know that the impulse exerted on an object will be equal to the change in total momentum.
By Newton's third law, we know that when Braden and I push away from each other, the forces exerted on each of us are equal and opposite. Because of this, the impulse on each of us is also equal and opposite. And by the impulse-momentum theorem, the change in momentum is equal as well. Since I have more mass than Braden, he will experience a greater change in velocity and go farther on the ice. The concept of impulse is useful in hockey when catching a pass. Since the change in momentum will remain the same, an increase in the amount of time will decrease the force exerted between the puck and the stick. This is why when catching a pass, I've moved my stick back with the puck so it doesn't bounce off.
This concept of decreasing force by increasing time can be applied in more than just hockey.
It can also be used in other sports like baseball or lacrosse. It can also be used to save lives in car accidents with airbags. The law of conservation of momentum states that momentum will not be gained or lost in a closed and isolated system. If two objects collide, their total momentum will be equal before and after the collision.
The law of conservation of momentum only holds true in an isolated and closed system. For a system to be isolated, the net force on the system must be zero. For a system to be closed, no mass can enter or leave the system.
By the law of conservation of momentum, the total momentum in the system will remain constant. As one puck hits another, the momentum will be transferred to the puck at rest. The first puck loses most of its velocity as it is transferred to the second puck. The initial velocity of the second puck is equal to the velocity of the first puck before they collide.